Why was season cracking a major problem for historical brass components? Imagine finding a beautiful brass cartridge case in an old military collection and seeing it suddenly crack apart. That's what happened with many brass parts used long ago. Let's find out why this was such a big issue. Season cracking is a type of stress corrosion cracking. It happens when stressed brass is exposed to ammonia in a moist environment. This was first seen in brass cartridge cases stored in stables during the rainy season in British India. The ammonia came from horse urine, which mixed with moisture and stayed on the brass. The residual stresses in the brass made it even more vulnerable. Brass components, especially those made by cold drawing or cold working, have leftover tensile stresses. These stresses are like tiny pulls inside the metal. When ammonia contacts the brass, it reacts with the copper in the alloy to form a water-soluble compound called cupramonium ion. This chemical reaction weakens the metal at specific points, especially along grain boundaries or weak spots. Cracks often start at stress concentration points, like where the brass was crimped or shaped tightly. These cracks are usually deep and brittle. If they grow large enough, the brass can suddenly break apart. In ammunition cases, this could cause misfires or even dangerous accidents. The cracks grew slowly during humid seasons and then became visible when the environment dried out, which is why people called it season cracking. The environment played a big role. High humidity kept ammonia in contact with the brass longer, speeding up the corrosion process. When the dry season arrived, the cracks were already well developed. This made it seem like the brass was cracking only during certain times of the year. From a mechanical failure point of view, season cracking is a classic example of stress corrosion cracking. It combines the effects of residual tensile stress and a corrosive environment. The chemical attack is localized, often along grain boundaries, making it hard to detect before failure. To fix this problem, manufacturers learned to relieving residual stresses by annealing the brass after forming. Heating the brass to a specific temperature allowed the internal stresses to relax, making the metal less prone to cracking. Also, storing brass components away from ammonia or humid environments helped prevent the problem. Understanding season cracking helped improve how brass parts were made, stored, and handled. It showed the importance of controlling residual stress and environmental exposure to avoid sudden, costly failures. This knowledge was especially useful for military and industrial applications, where safety and reliability are vital.